Hi everyone, Assalamualaikum. In this video, we are going to discuss integration by trigonometric substitution. We recall back what inside this chapter, which is integration technique. We already discussed number 1, integration of rational function using partial fraction, and number 2, integration of trigonometric function. So in this video, we will continue with integration by trigonometric substitution, right? Learning outcome. At the end of this session, the student should be able to, number 1, recognize terms in the given integrand which lend themselves to trigonometric substitution and decide which one to use. For a term of the form square root of a squared minus x squared, use x equals to a sin theta. For a term of the form square root of a squared plus x squared, use x equals to a tangent theta. And for a term of the form square root of x squared minus a squared, use x equals to a sec theta. And number 2, apply an appropriate trigonometric substitution to a variety of integrals. Now we look at what inside integration by trigonometric substitution. Right? When we want to integrate function with radicals, sometimes we need to eliminate radicals using trigonometric substitution. There are 3 types of radical function using trigonometric substitution. And before that, what is radical? Right? From cubic root of 27, 3 here means index. Right? Square root of cubic root of 27 is called as radical. 27 is called as radicand. And this symbol is called radical symbol. Okay? So this is radical. Right? Right, now we look back. There are 3 types of radical function using trigonometric substitution. Number 1, square root of a squared minus x squared. Number 2, radical square root of a squared plus x squared. And number 3, radical square root of x squared minus a squared. A here means constant, right? When we have radical a squared minus x squared, we need to use substitution x equals to a sin theta, right? When we have radical a squared plus x squared, we need to use substitution x equals to a tangent theta. And when we have radical x squared minus a squared, we need to use substitution x equals to a sec theta, right? And when we use substitution x equals to a sin theta, we can use identity 1 minus sin squared theta equals to cos squared theta. Okay? And derivative of sin theta d theta equals to cos theta, right? When we use substitution x equals to a tangent theta, we can use identity 1 plus tangent squared theta equals to sec squared theta. And derivative of tangent theta d theta equals to sec squared theta. Okay? And when we use substitution x equals to a sec theta, we can use identity sec squared theta minus 1 equals to tangent squared theta, right? And derivative of sec theta d theta equals to sec theta tangent theta, right? We look at example 1. with term containing radical square root of a squared minus x squared, and we take x equals to a sin theta, where a is a constant, right? Evaluate integration of x cubed square root of 4 minus x squared dx using trigonometric substitution. Right. Using trigonometric substitution, first step, we take x equals to 2 sin theta. Why we take x equals to 2 sin theta? From the given radical function here, we have square root of 4 minus x squared. And then we can compare from the formula, right? So from this formula, we have square root of a squared minus x squared. And we take x equals to a sin theta. Okay? So we can write square root of 4 minus x squared equals to 2 squared minus x squared. And when we compare, our a equals to 2. So we replace our a here. Okay, we replace 2 here. Right? Alright, that's why we get x equals to 2 sin theta. Right? The first step is very important. Right? And after that, step 2, we need to find x squared, because from the formula, we have radical containing x squared. Okay? So from here, we square on both sides, so we get x squared equals to 4 sin squared theta. Alright? From the given question here, we also have x cubed. So we can find x cubed. Okay, to avoid error, we find x cubed from step 1. Never find x cubed from step 2. Right? So from step 1, x equals to 2 sin theta. So our x cubed equals to 2 cubed, which is 8. And then sin cube theta. Alright? And after that, step 3, we need to differentiate from step 1. Right? From step 1, we have x equals to 2 sin theta. When we differentiate x with respect to theta, we have dx over d theta, which is equals to 2 cos theta. Right? D theta here comes from over d theta from left hand side. Right? But we need to write dx as a subject. So that's why we move d over d theta here. Right? And after that, step 4, we need to eliminate the radical from the given question. Okay? From the given question, we have radical square root of 4 minus x squared. Right? We can write equals to square root of 4 minus, we replace x squared equals to 4 sin squared theta. Right? And from here, we have same constant 4 and then 4 here. So, we can factorize 4. So, we get this. Okay? Square root of 4 times in bracket 1 minus sin squared theta. So that when we expand, we will get back 4 minus 4 sin squared theta. Right? And then from here, we can write 1 minus sin squared theta equals to cos squared theta. Right? Why we get this? From identity. Right? From the first trigo identity, we have cos squared theta plus sin squared theta equals to 1. And when we write cos squared theta as a subject, so we have 1 minus sin squared theta. That's why we get this. Right? And after that, we can simplify square root of 4, which is equals to 2. And square root of cos squared theta equals to cos theta. Right? So from step 4 here, from radical 4 minus x squared, this term containing radical. but no trigonometric function. And after we simplify using identity, now we have no more radical, but with trigonometric function, right? Right, after that, we need to substitute step 1, 2, 3, and 4 into the given question, right? So therefore, from the given question, x cubed times square root of 4 minus x squared dx, from here, we substitute step 1, 2, 3, and 4, and we write in terms of variable theta and d theta. Okay, so we get this. Okay, let me check one by one. We replace x cubed equals to 8 sine cube theta from here, right? We replace square root of 4 minus x squared equals to 2 cos theta from here, from step 4. Okay, and we replace dx equals to 2 cos theta d theta from here, right? The original function we are given in terms of variable x with radical. After we substitute step 1, 2, 3, and 4, now we have no more radical function, but we have trigonometric function with variable theta, right? From here, we need to simplify. Okay, we simplify the constant and we move out constant from integration sign. So we have 32. Okay, 8 times 2 times 2 equals to 32. And then integration of sine cube theta. And then cos theta times cos theta equals to cos squared theta. Right? And then we need to integrate. So from here, we need to integrate trigonometric function. Okay? But when we compare from appendix, there is no formula to integrate sine cube theta, cos squared theta, d theta. So what should we do? Okay? We need to identify the powers of sine and cosine. Okay? If we have odd powers of sine or cosine, so we need to use U substitution, right? Alright, but from identity, we have term containing square. Okay? No term containing cube here, right? So what should we do? First, we need to write sine cube theta equals to sine squared theta and then times sine theta. We put sine to the power of 1 theta at the back before d theta. Alright? Why we need to write sine cube theta in the form of sine squared theta? Because from identity, we only have term containing squared theta. Right? But to get back sine cube theta, so we need to multiply by sine theta. So that sine squared theta times sine theta, we will get back sine cube theta. Alright? And then from sine to the power of 1 theta here, okay, and when we use U substitution, we choose U equals to cos theta. We refer from here to choose U. Okay, so from sine theta, we choose U equals to cos theta, not sine theta. Why? Because when we differentiate U with respect to theta, so we get du over d theta equals to negative sine theta. So from here, we get term containing sine theta because we need to simplify sine theta here. Right? And every time when we use U substitution, we have derivative part and integration part. Under derivative part, we need to differentiate. Okay? And after we differentiate, we need to write d theta as a subject. So we just cross multiply. So we get d theta equals to du over negative sine theta. Alright? And after that, from identity here, okay, we can write sine squared theta equals to 1 minus cos squared theta. Why we need to write in terms of cos squared theta? Because we identify u equals to cos theta. When we use u substitution, we need to write all terms in terms of u and du. That's why we need to write sine squared theta equals to 1 minus cos squared theta to write in terms of u, because cos theta equals to u. Alright? So let me check one by one. From u equals to cos theta, so we can write cos squared theta equals to u squared. And from d theta equals to du over negative sine theta, so we can replace here d theta equals to du over negative sine theta. Alright? And after that, we can simplify sine theta and sine theta in denominator. That's why when we have sine theta, sine to the power of 1 theta, we need to choose u equals to cos theta, not sine theta. So that when we differentiate, we will get term containing sine theta, then we get d theta equals to du over negative sine theta here, and we can simplify with sine theta here. Alright? Alright, and then from here, when we use u substitution, we need to write all terms in terms of u and du. So from cos squared theta here, we recall back our u equals to cos theta. So 1 minus cos squared theta equals to 1 minus u squared. Right? This is what we get from the previous slide. Right? And then we simplify sine theta here and sine theta from denominator. Okay. And from the previous slide, when we use u substitution, we choose u equals to cos theta. So we can write 1 minus cos squared theta equals to 1 minus u squared. Right? So it is equals to 32 and then integration of 1 minus u squared. And after we simplify sine theta and sine theta from denominator here, we have du over negative 1, which is negative du. Okay? Or we can put negative for u squared here. Right? So we can write 1 minus u squared times negative u squared times du. Right? And after that, now we have term containing u and du. Okay? But before we integrate, we need to expand first. Okay? We multiply negative u squared and negative u squared here. And we multiply negative u squared by 1 here. So we get 32 and then positive u to the power of 4 we put in front, and then minus u squared du. Alright? And after that, from here, we can integrate with respect to u. Okay? Because all terms containing u and du. No more variable theta. Alright? So after we integrate using power rule, we still have constant 32 in front here, and then we integrate u to the power of 4 using power rule, so we get u to the power of 5 over 5. And then minus, we integrate u squared using power rule equals to u cubed over 3. We use power rule because n not equals to negative 1. Right? And after we done integrate, we put plus c for indefinite integral. Right? And then we can expand 32 inside bracket here. And at the same time, we can replace back our u equals to cos theta. Okay, so we can write equals to 32 over 5. And then we replace u equals to cos theta. So we get cos to the power of 5 theta. Okay, cos to the power of 5 theta means cos theta bracket to the power of 5. Alright, and then minus 32 over 3. And we replace u equals to cos theta. So we get cos cube theta. Okay, and then plus it. Right? Alright, from here, we done integrate. Okay, but when we refer from the given question, we have variable x here. And there is no term containing trigo or term containing theta. Okay, but after we done integrate, now we have term containing trigo. Okay, means that we not finished yet our solution. Alright, so we can naming it as equation 1. Alright, from here we need to rewrite in terms of variable x, okay, to get the final answer. But how? The way is to use the right angle triangle, right? So from here, we replace theta by x using triangle method, okay? So from the first step in the previous slide, okay, we take x equals to 2 sine theta. And then we write sine theta as a subject. So we move to left hand side here. So we get x over 2. Alright. From sine theta here means x equals to opposite and 2 equals to hypotenuse. So we can draw a right angle triangle. Okay. With angle theta. Okay. And then our opposite equals to x. And then our hypotenuse equals to 2. And then we need to find adjacent using Pythagoras theorem. Okay. And using Pythagoras theorem, we get adjacent equals to 2 squared, which is 4, minus x squared, and then square root. So we get square root of 4 minus x squared for adjacent. Right? Now, we have square root of 4 minus x squared, which is the same as radical in the given question. So, it means that our substitution x equals to 2 sine theta is correct. Right? That's how we check our first step is correct. Okay? If our step 1 is correct, means we will get radical, which is same as the radical in the given question. Right? And after that, now we want to find cos theta, because from equation 1, we have term containing cos theta. So from all three sides, from right angle triangle here, we can find cos theta, which is equals to adjacent, which is square root of 4 minus x squared, over hypotenuse. So we get cos theta equals to this function, okay? Square root of 4 minus x squared over 2. Okay, and then let's say we're naming it as, let's say we substitute into equation 1 here. Okay, so after that we substitute cos theta into equation 1 here. Okay, so therefore, from the given question, integration of x cubed square root of 4 minus x squared dx equals to 32 over 5. From here, now we replace cos theta equals to square root of 4 minus x squared over 2 from here. Okay, so we replace cos theta equals to square root of 4 minus x squared over 2 and then bracket to the power of 5 and then minus 32 over 3 and then we replace cos theta equals to square root of 4 minus x squared over 2 and then bracket cube and after that plus c. Right? And after that we can simplify. Okay? So after we simplify, we can simplify 32 here from the numerator and from denominator here. And then we can simplify 8 and 32 here. So we get 4 here. Okay. And after we simplify, so we get 1 over 5. No more denominator 32. And then bracket square root of 4 minus x squared to the power of 5 and then minus 4 over 3, no more 8 here, and then bracket square root of 4 minus x squared and then cube here and then plus c. Okay, this is the final answer when we integrate x cubed square root of 4 minus x squared dx. Okay, we need to use trigonometric substitution. Okay, but after we use trigonometric substitution, we need to integrate trigo function. Okay, so after we integrate trigo function, we need to replace back the trigo in terms of variable x. Alright, got it? Coming up next, integration by trigonometric substitution with radical square root of a squared plus x squared. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.